Hello, guys. Nice of you to join us in the morning or evening or whatever it is, apparently, all around the world. For me, it's way too early, but let's try to do some things. So I'll be talking about some APT I found a year ago and how they approach is makes easy to create an attack based on cloud tools. As it was said, my name is Maciej Kotowicz. I go by Mac in internet. I am independent malware researcher and operating out of malwarelab.pl, which I found. It's a small consulting, business doing whatever stuff you need from a threat intelligence to malware reversing and whatever in that area. In my free time, I play with Dragon Sector in some CTFs. And my main interest is reverse engineering and exploit development, as well as automatization and some formal methods in those topics. And there's some social media contacts to me, and my previous jobs, which was senior researcher at Great and malware owner at Third Polska. And the quick disclaimer is that most of this research was done when I was at Kaspersky, so I'm not. I cannot share much of the IOCs and what's not because they kind of owned by the Kaspersky Great and their private reporting services. But some of them are public, so if maybe there will be a blog later on, or you can reach me out, and I will gladly share what I can. All right, so first let's do some theoretics how to create an APT or whatever targeted like attack. It's kind of nicely. One second. It's nicely presented by this chain of infection or whatever it's called. So we have these simple steps, right? Like reconnaissance, weaponization, delivery, exploitation, installation, command and control, and actions and objectives. And action objectives will define as an exfiltration of data, basically stealing some documents as we want to have a espionage or whatever like campaign. And reconnaissance is something we kind of not relying on a cloud, so we'll skip that and we'll go through different phases of what we need to actually achieve that. So first thing we need is kind of some way of storing files, both the one we actually we want to steal and the one we want to host to maintain or recreate an infection, basically. And with that, using a payload host, we can host payload on a cloud storage services and just expose the files to everyone. And the same, we can exfiltrate our data to those cloud storage providers. And all the history, like the Dropbox, I think is the most popular in that stage of dropping files, delivering payloads, and also Google Disk, Yandisk, or whatever you want to use that. It's a perfect solution because it's kind of it's free and it's easy to set up. Next, we need some way to some sort of computing and power, and we have the solution for that anyway. We don't need to set up all buy the dedicated servers. We can use just the platform as a service providers or some shared free hosting, which is we'll use it for one campaign and get it removed after one or two callbacks. So it's not easy for the researchers to catch up because most of the malware analysis is kind of a retro job, right? We work on an attack that already happened most of the time. So we can get our C2 callbacks and the intermediate stages or whatever on those free platforms without any problems and without any, well, if you do it properly, without any risk of exposing it ourselves. And Firebase and Heroku will be the one that I will recommend for that. Also, WebHost. WebHost has a bunch of different projects, basically a free hosting, and it's abused by APT actors for a long time, and they're very proud of it and well fond of it. And at the end, we need some way of to provide the infection, and maintaining the infection, right? So the first thing will be getting some exploits or idea how to exploit the vulnerability, and then get some malware, and we go obviously for GitHub on that. And that's more or less the bricks we need to create an APT attack, basically. And we'll little bit go through how the fishing elephant and why the name came out of it. So the thing that we cannot overestimate in creating a campaign is having good lures. The thing that sending the spear phishing document, basically, because that's what everyone is doing, and it's still working. It has to contain some document that is will convince a victim to click on it and get infected. So what they did in the first campaign, they start sending CVs, because CV is something that if the company or the institution is recruiting, they will more likely click on it to get the candidates and candidates information. So they didn't send the documents itself. They sent the link to a page that they hosted on Heroku this time, and that mimicked Google Docs, Google Drive basically, and their interface for showing and opening files. And since it was quite some time ago, I think at the time the URLs were kind of similar to the one that's presented in a screenshot. It was quite cryptic, so for the normal user, it was pretty okay to actually click on it, and it was SSL enabled. Yeah, so no problem there, and it looks normally like a Google Docs, so it got a pretty good rate. If we click on it, the download button, it was a simple HTML file, HTML page with a bunch of JavaScripts for detection of browsers and doing proper redirects. We'll get this small HTA that will launch in our browser. Right, it's a simple stuff. It will open. It will download the next stage. Well, the final stage, the malware. And open a Chrome browser with a Google Drive link, which will actually shows the actual document, the CV that's supposed to be sent. So from a user perspective, it was more or less invisible to actually see what's happening. Obviously, the browser here was depending on the browser that came to the user agent from the browser that came to the staging page, right? So if it will be Firefox, it will Firefox open Firefox. If not, if it will be Internet Explorer, it will be Internet Explorer, blah blah blah, right? Chrome. Then you can see that there is a PowerShell used for the downloading, and the URL is hidden by using Bitly, which will be important later. Okay, and that's got a pretty good infection rate, but it's yeah, so it gets pretty good infection rate, right? Some summary of that, if you didn't saw it on the slides and I didn't mention it properly. So there was a spear phishing email with a fake Google Drive, docs lookalike app hosted on Heroku, and that's actually why the name of the actor is from the phishing part, because when I was seeing it, it was very much like a normal phishing applications, not the malware campaigns, right? We host something like that to get credentials, not to drop malware most of the time. These guys went a little bit further and decided to do some infection instead. The decoy image hosted is on a Google Drive, bunch of them actually, and they're still there for a long time. Then they get opened by the browser, so there's more or less no suspicion, because if you have a browser already opened, you open the same browser, it will open this new tab, not the new window in most configurations. Some hindering of the payload by Bitly, and the payload was hosted on the cloud storage services. It was mostly Dropbox, some Yandex disks, Asus Web Storage, bunch of different stuff, depending on the lure that it was used. This is quite a complex scheme, so they decided to, like, with the dropping the HTA. I think it was also relying on. No, it wasn't relying on anything. It was you need to convince user to click to do basically 2 clicks, because he needs to click on a link in the email, and then on a document that was dropped. So maybe, I don't know, they decided it's not a good idea, or it was too complex, and you cannot. At the end, the CVs are only good for a short period of time, because maybe their target didn't recruit anything or was closed in that area. So they decided to move towards more convenient, more typical approach, spoofing some emails from big names and using the documents of current events or the events that were happening inside of the target. Like they managed to get some names of the internal documents, or or guess what will be sending the different documents about day-to-day work. My guess is they get it from different phishing campaigns they're probably doing. I never managed to connect the dots if it's actually them, but it's most likely them. What they're doing, they're setting up the fake Zimbra servers and phishing for actually email accounts as well to get the point of the way of sending emails to the victims from legitimate organizations from within. So this will get like this fancy email from government of Afghanistan with some document. So pretty convincing to open. Inside DDE comments to get another payload. Again HTA. Again hosted on Dropbox. Some simple stuff. This time not PowerShell, but BitsAdmin is used. So they found of living off the land, or whatever you want to call this approach of using services that are already on the disk and not putting very much effort into creating their own stuff. So we get this. The payload is more or less the same. It will use again the BitsAdmin to get a payload and load it to the registry, to get some persistence. More or less the same template for RTA. So I'm pretty sure it's actually from some builder that they didn't found yet. And this time the modification was that they used actual IP addresses of some dedicated servers instead of cloud service. But you need some diversity at the end. Infection goes pretty nicely. So spear phishing with reference to internal documents and current events. DD abuse to fetch second page. This time there was no decoy document. Basically, the first document was just a blank page and nothing else. I think that's kind of a bad craft. It's supposed to. I think it should show something at the end, so the user is more or less sure that the document he saw was actual legit document and the real one. But no, at the end, every other day someone can slip off. Relying on the off-the-shelf tools, BitsAdmin, I think I found different ones as well, but I don't remember which one right now. And again, payload link was hindered via Bitly at some point. Later on, they were very fond of and rely on some third-party service that was actually generating links, the shorter links through this third-party site that will then redirect to the final destination. I think maybe for a statistics collection or what's not, but it was very easy to actually find them due to that, because it stand out very, very nicely. And you'll see the link at some point later on. And the third type of campaign I found in the beginning of this year, they added the geofencing to this first stage. So they want to maybe concentrate more on the countries, victims from the specific country. So it was harder for the attackers, for the researcher, actually for me, to find out what's going on, because if you call directly the app that was hosted again on Heroku, it was this time it was simple PHP file, I think. Yeah, so you get a redirection to the Dropbox. The HTA again got on a Dropbox, but it was Bainin one that will just start the Windows Update service. So it's still pretty strange to see if you go for the document and it's trying to download the document and you open the it starts opening the Windows Update service, but I don't know the decision. It was also using the DE as well, not the nothing else. So this basically change was that they moved to the more fingerprinting on Heroku, and if you manage to get a proper payload, it will download some text file from Dropbox again, and the text file was mimicked as a certificate. So they can use certutil to basically base 64 decode the payload into the actual exe. So it has all of those nice header and footer from certificate, but then like it was a simple base 64 encoded binary. So if you look at it for a few seconds, it actually stood out because of the size and not because of the starting bytes that didn't match the proper SSL certificate. But then they can use this nice tool to actually decode it, and they don't besides the simple PowerShell being invoked, there is not much of a suspicious comments being executed, right? And some persistence done with the registry. Okay, so that's how you get to the system. Pretty easy. You get to the system, and if you get to the system, you need to drop something because you need to maintain a connection. And having only PowerShell-based stuff, well, it still needs some sort of rat or backdoor. Obviously, if you need it, you go for the GitHub. It hosts a lot of tools like that for the educational reasons or whatever you want to call them. Even have some tags. So go rat, backdoor, or there is a curated list of all the nice things you can get and basically compile your own malware and have it dropped on a victim machine without being able to with actually bypassing all of the code based attribution systems. Sorry. What they settled down was for old Python rat named rs. They took some very, very old version of it. It's already not being developed for 3 years, and I think they took the one like from 2017 or something. That's more or less when I'm assessing the starting the campaigns. So probably they found one and said, it's okay, because at the end they're not doing much on the computer. They're just dropping the malware and dropping some commands to get steal the data, as I will show you later. So what this little bit modded rs can do, it can upload file, download file, zip some files or directory. I don't never seen used by them. Change directory and execute cmd.exe commands, which is the most. They basically what they do, they download the file from them from Dropbox to bunch of files to Dropbox, from Dropbox to the computer and execute them with cmd.exe and do stuff what they need to, what they're supposed to do. It's not obviously not only them using open source tools for the infection. If you go for some statistics from Aniran, for example, you'll see that on the top of their list, most of them are either open source or leaked or cracked, which is basically the same, because you can build your own stuff and have it deployed pretty easily. So yeah, maybe that's a little bit of a problem, or I don't know, maybe not. Hard to say right now if it's a good thing that it's so so easy to get malware, or maybe it's too much. Okay, exfiltration, because that was the other very interesting part. They get to the machine, they get a control of it. Now they're after documents. So what they did, they dropped the PowerShell, another PowerShell script that will download 3 files. Actually, those files I think they're still on the Dropbox as well. System.exe, temp.exe, and rclone.conf. And rclone.conf is very nice stuff, because those 3 files, one is system.exe is basically the real name is rclone.exe, and they have those hashes, and tmp.exe is 7-zip. So even if their payload or their RAT already had the zipping capability, they decided it's not worth to using it. Let's drop a 7-zip binary and use it as a compressor. And rclone.conf was a configuration file for this rclone.exe, and rclone.exe is basically a simple command line tool that's used to managing cloud storage. It's written in Go, so it's pretty nicely. It's one big static binary that you can drop and don't care about anything. So very nice, very nice. That's something you want to have when you pwning different machines. Static binaries are the thing that if you rely on them, that's pretty nice, because they will more or less work everywhere. And what you have in this what you have in this file is some access tokens to get to the Google Drive, basically. So what they did with those files, they dropped another. They will drop another another batch file that will iterate over all the disks and will look for all those documents and compress them and use this rclone utility to push them to the Google Drive. And those commands are also hosted on the Google Drive as well, in the same one, in form of documents. So there is another binary that I never managed to find that will be take caring of those. Oh, sorry. If you look closely, there is this .rb extension, and all of those previous ones are either related to documents or scans or what's not. But .rb are for the keylogger, and I never found the keylogger, unfortunately. For a long time, I thought it's supposed to be Ruby scripts for some reason, but no, it's for a keylogger. I'm suspecting it's also some sort of open source keylogger, but I never found it, unfortunately. If someone knows the one that's actually have this, and I think Lua was the other one, the other extension appended to the keylog file, please let me know. I will be happy to talk about it. So what they did, get the files, compress them, and push them to the Google Docs, and be done with it. Clean up, problem solved. Unlimited storage, no problem. Okay, so pros and cons of these solutions. From attacker point of view, obviously. So they are free for the most part of it. If you're not exfiltrating terabytes of data, because that will be a problem, I think, and it will be at some point maybe caught by the organization anyway, if it starts seeing the spike of data leaving the company or institution or whatever. So it's free, it's easy to set up. Basically, you need to click a few buttons and have all of the things you need working. It's hard to figure it out from researcher point who's actually using. So basically, the attribution is kind of tricky because there is no well, depending on a service, it's not much possibility to say who's owns the links. If you want to get fancy, you can get an easy and scriptable access to your assets, because those cloud services mostly expose some sort of API. And using open source tools, and you can kiss code-based attribution goodbye, because everyone is using it. Maybe at least some people are. Well, it's not that only you. If you don't pick very obscure, very old stuff, most of the time you find some other ATR researcher or red teamer or actor or script or whatever using the same tool. And it's as you see, those files are lying there for some time, more than 2 years, and no one cares to take them down, except Heroku, which when I start talking to them, they managed to get shit done. create some rules to basically put them out when they start creating accounts. So maybe they will move to a different provider, or will still try to get something on Heroku, and we'll manage to catch them again and again. Obviously, if there are some pros, there has to be some cons, and most of those services leaves a lot of metadata, and using Bitly or whatever, most of the payload shortening stuff, it will collect some clicks, maybe some geolocation based data from who's using the service, and it's available to most of the people there. There are some services that will create a unique link to get statistics only for the owners, but it's not very popular. And in this case, they used this jlworkshop.com as a base of creating those short links. So as you can see, it creates quite unique URL pattern one can hunt for in their logs. So that was pretty easy to actually find them and combine and collect all of the data about their attacks using those links. And that's for Bitly. If you go for Google, for example, for those documents, they also again contain a lot of metadata, including the one more thing is important, that there is a timeline for that attack, right? You see when when the most clicks happen, and that's probably the timeline when they started the attack. The rest probably is some researcher automating system or what's not. And again, the same situation for Google. You have a name for the guy or girl in this time, this case, or the fake account that uploaded. And if your OPSEC is bad, it's possible to basically correlate all of those because you will using the same Google account. It wasn't the case here, but well, it was to some extent. So some of the documents were shared by different emails, but mostly there was some correlation between them as well. And again, and there is those huge amount of data you get from querying the API. You get also the times of uploading, modification, and what's not. It's especially nice for their comments because they're hosting as well on the Google Drive. And if you get a ID, you can see that they're modifying the every day to change this one part of. If you look closely, there is a date somewhere in the in a disk name. Oh yeah, in a folder name. So they're modifying the disks, the documents every other day to change that. So I know they are still operating, basically on tracking the changes in those documents. And the other fun thing is, and it's kind of bracing on it's kind of on a edge of things. The good behavior is that they leak API keys, right? To those they need API keys to manage those resources, and if they leak them through the binary, basically, or through the scripts, that's not only them who has those keys. The victims and the researchers obviously have them, and they can do stuff about it. If they didn't properly configure the API access, well, things can get ugly. And as I said, in case of Heroku, they did quite a good job with creating rules and detections for their activities. So it's obvious that cloud providers, cloud operators has a different visibility into your stuff. If you rent just a dedicated server, it's more or less done, right? The only thing that admin can do can maybe restart it and put it in a rescue mode and then get some shit done, but then you will see it. With a cloud operator, it's not that obvious. Summary to finishing to get you some more information about Fishing Elephant. It's a new actor, more or less. As I said, I found him. I traced their steps back to So something is happening. Okay, so I found them in I found them in last year-ish or something. Traced their steps back to 2017. This is not a sophisticated actor. Um, they don't have any in-house development. At least I don't think so. And I never, as I said, I didn't found the keylogger, but I'm suspecting it's not the in-house based developed anyway. I like, however, how they use different methods to glue their attacks together. So they show some ingenuity in that. I think the main thing is heavy reliance on PaaS and cloud storage services. I didn't saw any group that's doing the same, that is doing it that heavily. They target mostly southeast part of Asia. I don't really know where they're from. I have some ideas, but unfortunately I cannot tell that. Maybe, drop me an email if you're interested. I can share some attribution stuff as well. And as I said, they're probably relying on a phishing to get some access to email servers. I saw some domains being set up and some information that support this thesis, but there's not direct connection yet. And they are very hard to catch. And I found only like 2 or 3 samples that are available publicly, basically on VirusTotal. And didn't manage to find them since January this year. And I know they're operating because I'm seeing how they're changing the comments and getting new infections. Cloud relying attacks, summary, easy to set up, hard to take down, hard to detect because the URLs are more or less legit, and hard to attribute if the service for like Dropbox, for example, doesn't show any metadata. But for Google and other stuff, there are a lot of metadata we can use. So it's kind of, depending on what tool you use. Sometimes you have metadata, sometimes you don't. And access to accounts most of the time is shared with victims and researchers, which can lead to funny stuff. And that's all from me.